Hello again, students. This is Miss Tittle. Now we're going to talk a little bit about your lab report for Inquiry 1.2, Scaling the Sun, Earth, and Moon System. First, let's talk about scale. When you're talking about scale, we're talking about the size of maybe a model of something. Like think about if you have like a toy car, like a Hot Wheels car. Then that Hot Wheels car is probably like, I'm just making a guess here, maybe 240 times smaller than a real car. So the model would be 1 to 240 times smaller compared to the real car. Or maybe like, let's use an example the girls might can relate to more, boys might can relate to the Hot Wheel cars more, but what about a Barbie doll? A Barbie doll is not the same size as a real human. They are a model of a human. So maybe they are like, let's say, 100 times smaller than a human. I'm just guessing. I'm just making a guess there on the scale. But you can see what I'm talking about as scale. The scale of something is going to be in comparison to the real thing. So in this lab, you're scaling the Sun, Earth, and Moon system. So our question for this lab is, how does the Sun compare in size to the Earth and the Moon? Now we want to both think about this in real terms of how big the real Sun, Earth, and Moon are, but we also want to talk about these in relative scale terms of things that we can compare them to. So for our hypothesis, if the Sun is the size of a blank, then the Earth is the size of a blank, and the Moon is the size of a blank. So what I want you to do is think about things. Now, those of you that will be live in class when we do this inquiry, we will be using a 12 centimeter globe. We'll be using some little tiny spheres and things like that. But those of you at home, or those of you who are working on this virtually in some way, think about different size spheres. A sphere is like a circle, basically like a circle. Let's think of it like a three-dimensional circle. Think about things like a basketball, a marble, a ping pong ball, a baseball, a softball, a beach ball, those really large exercise balls, Epcot Center at Disney World, anything that is like a big old circle, or even a really tiny circle. So think about the size of the Sun, the size of the Earth, and the size of the Moon, and for your hypothesis, make a guess of some object that you could compare the Sun to in this blank, that you could compare the Earth to in this blank, and that you could compare the Moon to in this blank. Okay, remember, your hypothesis is just an educated guess, so there's no reason to Google this or anything like that. I want to know what you think in these blanks, not what you Googled or something like that. So make a guess and put it in those blanks. Now, the materials for this lab are listed in your online book on page 3, and the procedures for this lab are listed on pages 6 and 7 in your online book. And so let's just take a quick look at our procedures. Now, if you were at school, we're going to be using a sphere that you would have selected for the Moon in class, and you would have been using a 12 centimeter globe of the Earth. And then we're going to make a guess about how big we would think the model Sun would have to be in order to be in scale with our 12 centimeter Earth. But those of you who are doing this virtually, again, use some sphere that you can relate to, like a basketball, a ping pong ball, a marble, or any other kind of round objects like that. Okay, the second step says for you to read Scaling the Sun, Earth, Moon Systems on pages 10 to 13, and then you will have these questions to answer based on that reading selection. And these questions right here I put into the lab report. So let's go back to our lab report. Okay. For your data, you're going to collect some information about the real diameter of the Sun, Earth, and Moon from the reading selection, Scaling the Sun, Earth, Moon System on pages 10 to 13. You're going to collect some data from that reading selection about if we were using the Earth itself as a measuring tool, then how many Earths across would the diameter of the Sun be? And of course, how many Earths across would the Earth be? Well, that would be 1. And how many Earths across would the size of the Moon be? So if you read that reading selection, you'll be able to fill in the diameter column on the data table and the number of Earths across on the data table. And then right here, I want you to list what objects you would use as your model objects. Like what sphere did you choose to use to represent the Sun? What sphere did you use to represent the Earth? And what sphere did you use to represent the Moon? You can plug those into your data table right there. And then remember those questions that were in the procedures of the lab report. Those questions are right here as our analysis questions, and you can answer those by reading the Scaling the Sun, Earth, Moon System reading selection that's on pages 10 to 13 in your book. So let's take a look at that real quick so you can see what that looks like. I'll just flip over to pages 10, page 11, page 12, and page 13. So you can see that's what you would be reading to answer those questions and to fill in your data table. Okay, let's scroll on down in our lab report. After the questions, again, you have a few vocabulary words. Again, remember, like I said on the last lab, you use the glossary in the back of your textbook to define the words first. But if the word happens to not be found in the glossary, then use the Webster's Online Dictionary for definitions. And again, remember to use the definitions for the words that are most appropriate for how we're using them in science class at this point. And then the last step of your lab report is to write your conclusion. Your conclusion, again, is a paragraph with at least 5 sentences that summarizes what you learned in the investigation. Your paragraph should start by restating the scientific question of the lab, and you will then need to tell if your hypothesis was correct or not. And then the remainder of your paragraph should explain what you learned about, in this lab, the relative sizes of the Sun, Earth, and Moon, using evidence from your data. So make sure you use some of those numbers about the diameter of the Sun, Earth, and Moon, or how many Earths across they would be, or what items you used as your model objects. All right, thank you.